This is gate 1988 question. The using the Armstrong axioms of functional dependency. Okay, can you derive this? What is the statement we want to prove? We want to prove that, so if this happens, then this will happen. Okay, this is what we want to prove. This is what we want to prove. Now remember the proof number one. The proof number one, that is using Armstrong rules. Okay, that is using Armstrong axioms. Axioms. Okay, using Armstrong axioms. But this will be a tedious proof. Okay, yes or no? This will be a very tedious proof. Basically, only three rules we will use again and again. Those three rules we will prove again, we will use again and again, Okay, those three rules we will use again and again. So this will be a tedious, I can say this will be a tedious proof, tedious, boring proof. This is a tedious and boring proof. It will be a long proof, okay, because you will use them again and again. So this proof we will not see. Okay, there is no need for this. Of course, on the Gate Overflow website you can see. If you want, okay, this proof one, if you want, on the Gate Overflow website you can see. On the Go website you can see this proof. But this is boring, okay, tedious proof. So on the Gate Overflow website you can see this question, you can check it out, and there you can see this proof number one. But what is proof number two? What is proof number two? The proof number two is by closure. The proof number two is by closure. So in this you find the closure of x plus. In this you find closure of x plus. What is that? In this you find x plus. So x can determine x can determine y, and you can notice x can determine z. So x can determine yz. So x can determine yz. So x can determine yz. Okay, this is a simple. But what is another proof? Proof number three, that is by definition of functional dependency. That is by definition of FD. By the definition of functional dependency. So by the definition of functional dependency, what you can do? See, very simple, very simple. If x can determine y, just look at this. If x can determine y, like we know that, okay, if x can determine y, x can determine z. What it means? What it means? It means that if you put a here, and if you put a here, then should I put same value here? Tell me. These two values, they must be same or different? These two values, they must be same. Agree? They must be same, right? So they must be same. These two values must be same, must be same. So if I repeat this, this must be same. This must be same. Okay, this is happening because of what? So tell me, this is happening because of what? This is happening because of, because x determines y. Now tell me. Now, if you put a here, then these three values, they must be same or not? These three values, they must be same or not? They must be same. They must be same. This is happening because of what? This is happening because of what? So because x is determining z, that is the reason. Now can you notice? Now can you notice? Now. Okay, if you repeat this, this is also repeating. Now can you see this? Now can you see this? Okay, now can you see this? So x is determining yz also. So x is determining yz also. Is this clear? This proof. By the definition of functional dependency. By the definition of functional dependency. This proof is actually much interesting. Yes or no? This proof gives you more intuition, more idea. This proof will give you more intuition about the functional dependency. How these functional dependencies behave. This proof will give you more intuition. So this proof number three, this is more intuitive. This proof is more intuitive. Okay, let's see this. This is gate again. This is another question in gate 1988. Another question in gate 1988. Now we have to prove this. Can I give this question as a homework? Or only proof three I will give you. Okay, remember, this is the question, gate 1988 question. Very simple question. What we have to prove? A statement that we have to prove. So what we have to prove? Just tell me this point. We have to prove that if x determines y, and wy determines z, then xw determines z, then xw determines z, then xw will determine z. Okay, so basically if this happens, then this will happen. This is the symbol for derivation, this is the symbol for derivation, this is the symbol for inference. Okay, so what is the proof number 1? The proof number 1, that is Armstrong, okay, using Armstrong axioms. The proof number 1 is using Armstrong axioms, correct? Using Armstrong axioms. So this proof number you can find on Go website. On the Gate or Flow website, this boring proof you can find. Okay, using the Armstrong axioms. Okay, using those 3 axioms. Okay, 3 axioms. You can find this. So this you can find. What is the proof number 2? The proof number 2 is very simple, closure. The proof number 2 using closure. Using closure. So what you can do in this you find what is xz plus xw plus. In this you find what is xw plus, that will be xw. X can determine y, wy can determine z. So I can say that this will happen. So this will happen. And what is proof number 3? That is by functional dependency definition. That is by functional dependency definition. In the functional dependency definition also you can see that x is determining y and there is w. X is determining y, there is w also, there is y also, there is z also. Now the question is saying that x is determining y. So if I okay, and remember what we want to prove this. So if I repeat this, if I repeat xw, if I repeat xw, if I repeat this xw, if I repeat this xw, if I repeat this xw, remember if I do this repetition, if I repeat them, this xw, if I repeat xw. So if I repeat this xw, now what will happen? Now you can notice x is determining y. Agree? X is determining y. Because x is determining y, so it will repeat. Because x is determining y, so it will repeat. So it will repeat. So this will repeat. And because wy determining z, wy determines z, wy determines z, wy determines z. So this also will repeat. So this will also repeat. So from this I can say that xw will determine z. This is another GATE 1988 question. GATE 1988. It was obsessed by this Armstrong axiom. 3 questions in this single year. In 1 year, 3 questions back to back. 12A, 12B, 12C. This is a very simple yes or no. Is this true? Yes, this is true because x can determine y, right? This is your y. This is your y. And this is your z. This is your z. So of course x can determine z. So this is very simple. Of course this will happen.